Yeah, so I'm Pendleton. I'm the ex-Big Maps tech evangelist. I actually moved to the Big Mobile team about a month ago, but I had already committed to this, and I'm committed to the Seattle user groups, especially for Seattle. So I figured I'd come out and give you the spiel. I figure what I'd talk about today. First, if you guys are going to tweet about anything, feel free. It's all public information I'm going to share with you. But include my alias, because I like to read what you guys talk about me. So critical feedback about my presentation skills. So here's the agenda for tonight. Really appreciate you guys coming out. It's great to meet guys that will come out on a weeknight after work at 7 o'clock and talk tech. So always good. So I'll give you guys some treats. We'll talk about the content. I'll go deep on Big Maps just in general. I'd like to give an overview of what exactly Big Maps is. And because not a lot of people know or appreciate exactly how much work goes into Big Maps, and especially how much money goes into Big Maps. So I can talk about that. We'll talk about the content, the APIs, and the infrastructure. But tonight we're going to focus on the Windows Phone 7 control. Nobody from the Big Maps team has done a Windows Phone 7 control presentation, so this is all fresh material. I had to build a brand new deck in the last 24 hours. I mean, the last week. I spent a lot of time. And so we'll talk about the classes and everything that's available. I'll talk about how hard it is to actually do this, because from a developer's perspective, it's pretty easy, but if you want to read docs, it's really hard. So we'll talk about that and how you get around some of that, and then I'll actually do some code examples, and we'll build a couple apps. So then we do Q&A at the end, if you guys don't mind. So just to talk about Big Maps in general, there's a lot of information in Big Maps and a lot of services in the Big Maps, and that repository of information is available through a number of different protocols, a number of different APIs. And I'll talk about those in a second. But there's 4 major services that go into Big Maps. Geocoding is the main one, and that's basically converting addresses to lat longs. Everything that you want to do in the world and put it onto a map, you need to convert it to a coordinate. But if you have a coordinate, which we're going to talk about a lot today because we're talking mobile, you want to convert it to an address, you're also going to use geocoding, but you're going to you're going to use a service that we call reverse geocoding. So we have that. And we have over 85 million parcel centroids in the U.S. What that means is there's parcels of land around the whole U.S. And what our competitors do is they'll give you an estimate on the street, somewhere in the middle of the street, whereas Big Maps will snap to an actual centroid on top of a parcel. We'll also provide you with what we call interpolation, so kind of in the middle of the street somewhere. Also, in case you want some level of ambiguity, you don't want that level of fidelity, putting it right on top of a house. But with the adoption and the introduction of rich imagery, high resolution aerial imagery, people want that level of fidelity so you can see exactly where a house is. So, 85 million in the U.S. We added Japan and Germany as well. Those are live. And then and bulk geocoding. So that's part of a different process, but we have bulk geocoding. So if you have millions of records and you want to send them up to a batch system, we'll process those and then send you back the file, and we're done. We give you back all the platforms too. So lots of stuff there. Oh, and one of the keys, the key advantages of our geocoding system over our competitors is there's no daily limits. Apparently Google puts a big stranglehold on how many geocodes you can do per day. We get a lot of customers from that, so it's really great. I'd love to highlight that bullet point. The second of the 4 content layers is maps, right? The visualization of the actual data. And then there's 2 kinds of maps. We call it, road maps, which is kind of the cartoony maps, and then there's the aerial imagery. And the aerial imagery breaks down into several different factors, right? We've got what we call orthographic imagery, or 90 degrees to the ground, and then we've got oblique imagery, which is 45 degrees to the ground. And that's also named bird's eye, so perhaps you've seen that. We've got that for, we've got over 90% coverage of bird's eye imagery for the U.S. population, over 80% for Western Europe. We've got cities throughout Australia, Asia, Eastern Europe as well. So just continuing to grow the imagery data set. We also did a partnership, actually, switch slides. We also did a partnership with Digital Globe. And this is for our ortho project. So what we did with this global ortho project is we've committed to flying 30 centimeter resolution imagery for the entire lower 48 states and the major cities in Alaska and Western Europe at 30 centimeters. Like we're talking all the urban cities, which usually if you go on to like Bing Maps or Google Maps, you'll see there's a higher fidelity than you would get in the cornfields in Kansas. But we're going to do the cornfields in Kansas too. We're doing everything. The Badlands, I mean everything. So it's the biggest imagery project ever taken on. It'll be done in 18 months. So it'll be fairly new, and that'll cover, like I said, the entire 48 contiguous states in Western Europe. So it's a massive project. And then we'll just work with digital to refresh that data every 2 to 3 years. So huge investment on both companies. In fact, we manufacture the highest resolution camera on the market. It's called the UltraCam, and it came through an acquisition we did about 3 years ago with Vexcel Corporation. And Vexcel's camera system is amazing. In fact, we use about 5% of what it actually does, because it has all of these channels on it that record all types of information. We get, hydrology, we get vegetation. So we actually know the camera was created. This is an interesting story. The camera was created in order to determine the depth of oil wells once the oil was extracted, how much steam they had to push back into the earth so it didn't collapse. Like that was the impetus of this camera system, and we use it to take pretty pictures. So there's a lot that goes on with this camera, and in fact, it's got LiDAR attached to it, so we actually get stereo pairs out. And if you ever saw the 3D control from Bing Maps, we generated all the 3D buildings with nothing but software. So as we're flying over at 10,000 feet, capturing imagery, we're also shooting down LiDAR. We're capturing all these channels that we're not using yet. And we're able to put that into software processing, recreate the Earth in 3D with high-fidelity buildings, high-resolution building textures. So everything that you saw in the Big Maps 3D control was completely software-generated, except for 1 or 2 flight sim models. RIPs. So going back to the map data, so we partnered with Navtech to get all their base map data. So we use a lot of their data for the actual roads. We've got data around the world, but at street level, it's around 37 countries where we can actually get down to the street and see super high resolution or high fidelity route networks around the world. And we also introduced a new map style, which we've gotten mixed reviews on. If you're a cartographer, you hate this, because it obfuscates so much of the detail on the map, right? Cartographers, they're mapping people and they want more detail. But if you're an app developer, you want less detail because you care about the data on the map. So we're more focused on those guys. And so app developers love this new map style, because if I want to put my data on here, I don't want the background noise to bother my data. I want my users engaged with my application, my data, but I also want some location context in the back. This is important because we went with this map style for the Windows Phone 7 control. So yeah, good stuff. I was going to tell you something that's secret, so I can't tell you. The third content is routing. So we've got all these massive routing networks that we get from Navtech, and we've got algorithms to calculate the shortest, the fastest. We have walking directions. We just introduced transit directions on our consumer site, so you can basically walk to the bus stop using the walking directions. You can get onto the bus and take the bus downtown, and if you have your car parked there, you can drive somewhere. You can connect it all. It's multimodal. So we actually have traffic-based, or we actually have transit directions on our consumer site. It's not in the API yet, okay, but it's kind of close. Then we have a traffic-based algorithm that's pretty great. It came from Microsoft Research. It takes into consideration traffic flow. So based on traffic flow, we can provide you with alternate routes around traffic incidents and gridlock and whatnot, which is, there's not many alternatives for 520 and 90. But if you're in LA, if you drive through LA, you're on 405 going up through Santa Monica or something, or Hollywood, there's actually some nice side streets that you can bump on. So I grew up in Southern California, so that's hugely beneficial to me. And then we actually allow users to extract route geometry too. So the route geometry is the actual piece of raw vector information for the route, right? And why is that useful? Well, with SQL Server 2008, there are 86 spatial methods associated with SQL Server 2008. And by the way, they push those up to the cloud in Azure. So if you have data in SQL Azure, you have access to these 86 spatial methods. And if you have access to Big Maps, which you do, you can extract a piece of route geometry and do buffer searches around that route. Okay? take a piece of route geometry out, you send it to Azure. You've got data in Azure, and you want to know what pieces of information are within a mile of that route, half a mile within that route. You want to draw intersections around that route. You want to know which counties your route is colliding with, or intersecting with, or colliding through, or not intersecting with. This is the type of information you can get out of route geometries. So some fun things happening over on the SQL Spatial team that really coordinate with the efforts that we're doing in the big maps. And then finally, the fourth piece of content is search, and that's the yellow page listing. So we've got nearly 20 million listings in local search, probably more than that by now, because that goes every day. And that repository of local listings is accessible through the Big Maps APIs. So you get access to those too. And those are all by category, and you can do by location and categories, and there's all kinds of mix and matching you can do to get local listings out. I mentioned the developer APIs. We have quite a few. There's an Ajax API for you scripting developers. Everybody in this room is a scripting developer, right? You'll love the fact that we do have Silverlight control. Has anyone played with the maps, the big map Silverlight control? Silverlight user group. We actually, for the JavaScript developers, which is a lot more common for our mashup developers, we created a hosted ZAP file that they can script against. So, much to your dismay of the Silverlight users group, we actually created a scripting library to hit our ZAP file that allows JavaScript developers to do Silverlight development in their applications. So, that was kind of cool. It's limited in what it does because we were trying to drive Silverlight adoption, but it still works for the most part. We have a SOAP service that's been around for quite a while, and in fact, we have a legacy SOAP service that's been around too long. So, we're hoping that goes away soon. But the SOAP service that we kind of reinvented is much more robust. It uses a lot of the new .NET frameworks, libraries, and whatnot, for accessing those services. And then we have a REST service. So if you're into state transfer, we can do that too. That's good for mobile development. If you're using Windows Mobile, or Windows Phone, excuse me, Windows Phone. Mobile's dead, Windows Phone. You probably want to use SOAP service anyways. Super simple to link up with Silverlight. We have the Big Map App API. I wanted to bring that up because it is Silverlight based. And in fact, I'm going to demonstrate this. Let's see here. So on Big Maps, we actually have two Big Map sites. We're so great, we have two sites. So if you go to bing.com/maps, that'll take you to our JavaScript experience. If you go to bing.com/maps/explore, you'll get our Silverlight experience. And with that, we've got this concept of map apps. And what map apps are external third-party services that we've extended our reach out to, and we're bringing that data in through web services and mashing it into Big Maps. So we're not doing a mashup, we're doing a mashup.